Example number 4, making predictions that involve dependent events. This one is kind of like the epitome of dependent event type of questions. It involves cases, it involves a tree diagram. It's the real meal deal when we're talking about questions depending or questions about dependent events. So make sure that you certainly know how to do a question that looks like this. So Hillary is the coach of a junior ultimate team. Based on the team's record, it has a 60% chance of winning on calm days and 70% chance of winning on windy days. Tomorrow, there's a 40% chance of high wins. There are no ties in ultimate. What is the probability that Hillary's team will win tomorrow? So essentially what we have to do is, if tomorrow is a windy day, we have to calculate the probability of them winning. And if tomorrow is a not windy day, we also have to calculate the probability of them not winning. Oh, sorry, of them winning. So just to organize our thoughts, let's create a tree diagram. Okay, and this is easy. Either things are windy or not windy, you win or you don't win. So there are only 2 options for each. So let's first deal with the weather. Okay, that's from here to here. So the probability of tomorrow being windy is 0.4. Why? Because it says right here, there's a 40% chance of being windy. So that means the probability of it not windy is going to be 0.6. Because there's got to be a 100% chance of something happening. So it's either going to be windy or not windy. So the second tier here is going to be our game result. So given that it's windy, the probability, okay, so it says 70% chance winning on windy days. So if it's windy, that means probability of winning is going to be 0.7, and the probability of not winning is going to be 0.3 because there are no ties in ultimate. So if the day is not windy, it says it has a 60% chance of winning on calm days. So that's not windy. So probability of winning, it's a little less at 60%. Remember, this is just the decimal equivalent of 60%. And the probability of not winning would then be 0.4. So this is like cases. We must add them up. Okay, so I'm just going to highlight 2 different things. So we want the two branches that are winning. So we have to calculate this one, the probability of winning, and it's windy. And we have to calculate the probability of it being calm or not windy and them winning. So the probability of wind and wind is 0.4, so that's the probability of it being windy, and 0.7. So if I were just to go up here, this is like our probability of A, so probability of it being windy times the probability of them winning given that it's windy. Okay, so we're still using the same formula that we've been using all along. This is going to be 0.28 or 28%. The probability of no wind and wind, which is our pink leg of the journey, is going to be 0.6. times 0.6, which is 0.36. So the total probability of a win would be 0.28 plus 0.36, which is 0.64. Now again, this is terminating, so we can say or 64%, not needing to worry about those extra decimals because it stops right there.